here's a video to help you complete the practice test. And I'm just going to go through each part, and you can stop and pause and whenever you want. So remember, part of the test is converting to scientific notation. When you see standard notation like this, the decimal point isn't showing. It's understood that it's at the end here. So this is the ones place, and the decimal point always comes after the ones place. So that's the first thing to know. Then we're going to figure out how many jumps it is to move the decimal so that our coefficient, remember it's m is the coefficient, times 10 to the n, some exponent. And there's a rule, m must be between 1 and 10. So we're going to figure out how many jumps it takes to get the decimal point to the place where m will be between 1 and 10. So 1, 2, 3, 4, 5, 6. Now if I stop here, it's 67.2. That's over 10. So I'm going to go one more, 7 jumps. Now it's 6.72. That's between 1 and 10. Then we say times 10 to the 7, because the 7 jumps, if we multiply this times 10, 7 times, it will be the same number as we see here. So these are really the same number. Let's try it with a small number. Oh, I also like to remember, in case you're confused about the left and right, if it's a big number, it's going to be a positive exponent. Here's a small number, less than 1. So we do the same thing, but we move the decimal to the right this time to get it to the place where m will be between 1 and 10. 1, 2, 3. If I stop here, it's 0.33. That is not high enough. That's under 1. If I go one more, now it's between 1 and 10, 3.34. So I did 1, 2, 3, 4 jumps. That's between 1 and 10 times 10. Since it was 4 jumps and it's a small number, it's negative 4. Okay, when we're going back the other way, we look at the exponent. We're going to move 2 jumps. The negative sign means it's a small number. That helps me remember it's going to go to the left. So 1, 2 places, and then I'm going to write it here with a 0 to fill in that space. 0, 6, 0, 4, 1. Notice I didn't add 2 zeros because of 2 places. I moved it 2 jumps. Once around the 6, and one more that's held by the 0. This one, now it's a big number, positive exponent. So 1, 2, 3, 4, 5, 6, 7. So I have to add 1, 2, 3, 4, 5 zeros. 7, 5, 5, 1, 2, 3, 4, 5 zeros. If you want to add the commas, remember to start from the ones place. 1, 2, 3, 1, 2, 3. Okay. Molar mass. This is what we learned to do in E10.4. There's a video posted there. We're going to round to the nearest hundredth, show work, and include the unit. So CO2. Look on your periodic table. You see carbon 12.01. I'm going to show it with the parentheses this time. So 12.01, and there's only 1 carbon, so times 1. Plus, then I add to that the oxygen, 16. But there's 2 oxygen. So now I'm going to put this into my calculator. So we can do it with the parentheses here if we want. 12.01 times 1, parenthesis, plus, parenthesis, 16.00 times 2 equals 44.01. See, if I use this periodic table and I use all these decimal places, that's already to the 100th, 10th hundredth, 10th hundredth, then my answer will be to the 100th. The unit is grams, because this is mass, molar mass. Means it's the mass of 1 mole. All right, neon, I see Ne. Since it's an element, I just read it off the table. 20.18, it's already rounded to the 100th place, grams. Last one, Mg, 24.31. Okay, that's a little typo there, a little extra parenthesis. That's not a subscript, but there's just 1 mg. And now some of us are still making mistakes here. Remember, the Script on the outside of the parenthesis means there's 2 of everything in there, so it's going to multiply. So the n is 14.01, and there's 2 of them, 2 times 1. Plus, I still have another element, 16 again for oxygen. And this time, 2 times 3, there's 6 of those. Now I'm going to put those in. This time I'll do it a different way. You might want to do each of these separate and then add them again. So we know 24.31 times 1 is still 24.31. 14.01 times 2 is 28.02. And 16 times 6 is 96. You'll get used to, you don't always have to type in those zeros. We want them there to show we are in the thousandths place, but your calculator doesn't know the difference. Now I need to add these up. 24.31 plus 28.02 plus 96 equals, there's my hundredths place. I'm going to write all of that since it says to round to the hundredths place. All right, now I have some molar masses. Down here, let's read. Now this is one-step conversions. If you're wondering where we learned this, it's E10.5. How many moles are in 25.12 grams of magnesium nitrate? Round to the nearest hundredth. So I'm going to think about what is my given and what is my wanted. When there's a number already, that's given. They're giving you that information. So that's G for given. How many moles? That's a question that we don't know yet, so that's what we want to know. All right, so I'm going to start with the given, always, all the way over here to the right, the left, I mean, grams times. Now, I need to look at my roadmap. So I'm in grams. So when I look at the map, that means I'm here. And I'm trying to get to moles, so I go up from grams to moles, and it's this. There's my reminder that molar mass is what we got from the periodic table. So I'm going to put 1 mole on the top and the molar mass on the bottom. How do I know what substance to do for the molar mass? I look at the problem. It's this substance, which we just did up here. So it's this one, 148.33 grams. Grams are going to cancel. 25.12 times 1 divided by 148.33. Remember, we multiply across the top and divide by the bottom. Hundredths place, 10th, 100th, 1000th. I want to keep the 6 or maybe go up to 7. I look at the next place, it's over 5, so I'm going to go up. 0.17, and now this is moles because the grams have canceled. Remember, the grams are the given, those have canceled. The moles are what are left. Those are the wanted. All right, what is the volume in liters of 0.84 moles of neon gas? That's my given because it has a number. What is the volume in liters? So it's kind of said it in a long way here, but liters are really the unit I'm after for my wanted. Okay, and so 0.84 moles, I always start with the given every single time, over here on the left. Times a fraction. Use your mole map. I'm starting in moles because that's what my given is. I'm going to liters. Moles to volume in liters. Follow the arrow. 22.4 on the top, 1 on the bottom, 1 mole on the bottom. Remember, you don't need the molar mass unless grams are one of the units in the problem, and they're not here. So I don't need to use that for this one. It's just the volume ratio that we see here. Okay, 0.84. $18.816. I'm going to look at the hundredths place, and the next place over, if it's higher than 5, I go up. and the unit is liter. Remember, the units of the top match the end. Unwanted. Last one. How many molecules of CO2 gas are in 2.31 moles? There's my given because it has a number already. Here's my wanted. How many molecules? Now I'm going to put the given over to the left with the unit. And then it's a fraction. Then I look at my roadmap. I'm in moles. Here it is. This time I want to go to molecules, so I'm going this way. So it's this fraction that I need. From moles to molecules. 6.02 times 10 to the 23rd on the top. And that's molecules. And 1 mole on the bottom. Moles cancel. And then I do the math. Multiply across the top. 2.31 times 6.02 second E 23 divided by the bottom 1.390. So hundredths place, look at the next place, it's less than 5, so I stay 1.39, but notice it's got a times 10. That makes sense when we're talking about molecules. There are always a lot of those because they're so small. So I'm going to put molecules. So I'm going to be looking for, remember that matches. The correct answer is given with the unit. All the units are correct in the conversion, so we didn't have these upside down or something. We didn't go to grams when we were supposed to go to liters. We wrote our scientific notation correctly, and we rounded it correctly. All right. One last thing about the word molecule and atom. Since this is a compound, we're saying how many molecules. When if it's an element, then we would use the word atoms. Both atoms and molecules are tiny particles, so that's why there's 3 words sometimes used there. All right, good luck.